Hi, I'm Mike Seymour from fxguide and fxPhD. We're really proud to partner with LEMAC when they brought out Dedo Weigert from Germany, who's, of course, the founder of Dedo, the inventor of the Dedo lights, but so much more. A really skilled lighting cameraman in his own right, somebody that's an innovator right across a huge range of our industry. Well, I was privileged enough to sit down with Dedo and actually walk through the new LED range of lights that Dedo as a company have been pioneering. But before we looked at the specific product range of the new Dedo lights, I wanted to discuss with him some of the issues about LED lights in general, because as he himself has joked, people kind of assume that LEDs are the answer to all woes and will be the future of all lighting, and there are some aspects of that are true, but there are also quite a few aspects about LED lighting, kind of myths, if you like, that have built up over the years that we wanted to dispel first. Thanks so much for joining us. We really appreciate it. So I wanted to see if we could start by asking you about LED lights. I've heard you talk about lights, and you joked at the time that some people think that LEDs are the answer to all lighting, but in fact the quality of light is vastly different between the ranges of LEDs one can get, aren't they?
There are certainly a lot of differences that one should be aware of. LEDs are not all the same, and even if you think they are, they may not be. The expectations these days are very high. People think LEDs put out an incredible amount of light. They expect that they use very, very little energy. They expect that LEDs produce no heat and that they will live forever. And some of that is true. Some of it is fairy tales. But even at the bottom of fairy tales, there sometimes is a core of truth hidden. Okay. The light output of LEDs, of the actual LED light source, today is around 60 lumen per watt.
Okay.
And if you compare that with a studio halogen lamp, which in reality gives us about 20 lumen per watt, yes, that is quite a lot of light. If you compare it with an HMI, that's 80 lumen per watt. The fluorescents also give us 80 lumen per watt. The promotion of LED, as it's done by the manufacturers, often claims 100 lumen per watt or even a lot higher. And in the end, this will be reached. Now, the differentiation that we have to make is whether we are thinking of LEDs as used in street lighting or automotive lighting or exterior lighting for architecture, then this is a wonderful tool. But we may have slightly different demands when we're talking about professional lighting.
Well, in fact, quite strong different demands, because you yourself were pointing out the CRI of the lights at the street level. We really don't care about the colour rendition that much, but of course in professional lights we care about it an enormous amount. How hard is it to actually source the LEDs at the quality that you need?
Well, to evaluate LEDs, the seasoned camera person and gaffer would attempt to do that with his color temperature meter. And some of those also give you the values for green and magenta. Those are important aspects. But the traditional color temperature meters are the so-called tri-stimulus meters. Mm-hmm. They measure very narrow bands of the spectrum, which gives you a pretty good indication if you have a full spectrum light source. But already they give us approximative results when you talk about HMI, metal halides, when you talk about fluorescent, but when you're trying to evaluate LEDs, they give us totally wrong values. Then you have to go to spectrum analysis, and those are instruments that not everybody has.
So if I understand you correctly, what you're saying is I could measure a LED just roughly in terms of maybe its colour temperature, and it would appear to be the right colour temperature, but the colour wouldn't be what I wanted to have.
Even on the colour temperature, it gives you completely wrong results.
Really?
Yeah. So forget the old-fashioned colour temperature meter. You have to rely on spectrum analysis. And that usually then is interpreted in values of CRI. But when we look closer at CRI, that is 8 colors. And it does not include very important color evaluation like the R9, which is a full red. It does not include the R13 that we usually today attribute to skin color.
Okay.
So first we've got to change all this and work with an expanded CRI. And then we think we have a scientifically based answer. We can print it out. But then comes the real big surprise. CRI is something that relates to the human eye. But the digital sensor in the cameras that we use today, they see that very differently.
Now, I was stunned by this, and you explained it very well earlier, this idea that actually different sort of types of CMOS chips in different cameras will actually effectively render these colours generated by the LEDs and sort of react to them differently. And so, in fact, the CMOS has an active role in our colour here.
It's not only the CMOS. Now we're trying to go one step that is very important, and that was originated by the European Broadcasters Union, a British man, ex-BBC, called Alan Roberts, and he initiated the TLCI, the Television Lighting Consistency Index. And he's basing it on research done with 8 different types of studio cameras, of which 7 seems to have given him pretty similar results. The 8th one didn't. He never told us what the 8th one was.
Don't know what the 8th one is, right?
But those cameras are not, as you're mentioning, CMOS cameras. Those are cameras with a prism working with 3 CCD sensors. And that may not be indicative for interpretation of the CMOS. So all of these digital sensors may see daylight pretty much identical. They will see halogen light as a full spectrum light source, identical. They will see fluorescent pretty much identical, and metal halides also. But with LEDs, they show completely different color rendition results.
So you'd recommend maybe filming a Macbeth chart with some kind of standard light perhaps, and then comparing without changing anything else, just changing over to LED lighting and seeing whether they kind of match up.
So you film the multicolor chart, the Macbeth chart, or there are other ones also. Munsell, I think, was the history of it, of original these color charts. And you film such a color chart with a reference light. Well, what is our reference light?
Well,
like
yes.
Like there is one halogen lamp from the National Bureau of Standards, and if that's driven just the right way, it gives you a pure reference light for 3200 Kelvin, but that's not what we're using. So one is the scientific reference, and the other one is the practical approach from the DOP and the gaffer. What lights are we shooting with? And then in tungsten, that would be the attempt to match a studio halogen. So in the books, that is 3200. In reality, it isn't. The reality in the studio gives us more like 3000 or 2900. And here in the tungsten range, 200 Kelvin is a huge step. In daylight, 200 Kelvin is a very small step.
Because it's a logarithmic scale.
Yeah. Now, then we try to use reference light. Osram has a little reference lamp that comes very close to it, and we can use that as a neutral halogen source. Then you shoot the Macbeth chart, once with a reference light, once with the LED light, slice them together half-half in Photoshop, and then you can compare upper half, lower half, reference light and LED for color rendition, and nothing will match.
So this means that even, well, I guess in the broadest terms, all LEDs are not made equal. But a lot of that comes even from the manufacturing process, right? Where even inside batches, it's quite hard to get exacting results, and they have to sort of sort them.
But it goes even further. Then we also want to have the reference for daylight. And what is daylight? Daylight can be anything. I was shooting a film in Katowice, in a town in Poland, and according to the Kodak book, noontime, June, no clouds, you have 5600 Kelvin.
Well, that's what I'd call daylight, yeah.
Yeah, and I measured it, and it was 2800 Kelvin. Yeah? It was hellishly red. Why? Air pollution. So even daylight is very hard to pin down. So maybe we should use as a reference light possibly the KinoFlow, because those have become very, very good, and it's a standard of our industry. So we may want to match to that. But each modern digital camera may see that very different. So your camera-based tests will be very different whether it's shot with the studio camera with the 3 CCD sensors or with an Alexa. And I asked the inventor of the TLCI evaluation system, how about the Canon 5D? That gives us wonderful images.
Well, we're shooting with them now.
And he said, that's not professional. They just have to learn to live up to our standards.
Okay.
But that is not a statement from the real world. Then I asked about the Sony EX3 camera, because thousands of small producers are shooting with that.
Sure.
Or even the BBC, which is kind of like the Vatican in Europe. They specified that anybody who shoots on a Canon 300 series camera, that will be accepted by the BBC. And he said, well, the EX3 has a lot of infrared problems, so that doesn't count. But what we find, what we learn is you can't rely on it. You shoot your camera-based test, but that doesn't give a good indication for the next and the next and the next. Even shooting with 5 EX3s that we bought the same year.
Yeah. Still have variation?
Halogen light looks identical.
Yep.
But with LED light, we do see differences. Now, we shouldn't get overcritical, because color never was that good. Everybody shoots with HMI lights, and all the HMI lamps, even from the same manufacturer, even from the same batch, even same age, may give you different colors. They're quite individual. As they age, and even with different working temperatures, they give you different color results. Some age faster, some age slower. They're very like human beings.
You touched on heat there, and I wanted to talk about that in terms of LEDs, because heat's one of the things we might discuss as being a bit of a myth, that LEDs are not hot, and they obviously do generate heat, but the heat level that they're running at is very critical to their accuracy, isn't it?
Yes. People expect LEDs produce no heat, and that's a lie that is even bigger than what the politicians usually tell us. Halogen light, let's say the studio high voltage halogen light, 90% of the energy is turned into heat. 10% is visible light. And in the typical studio Fresnel, if you go to the spot position, you have an efficiency of 6%. That's 6% of 10%. That's 0.6% of the energy.
True, though I get a lot better if I use one of your original Dedo lights.
Yes, you get 3 times better, but still it's not a magic figure. So people expect wonders from LED, but they still produce a lot of heat. One thing is true, and it's a real advantage, the forward heat on the LED, the heat within the emitted light, that is lower. But on the LED itself, a tremendous amount of heat is generated, and if you don't take care of it, you have big problems.
So what sort of numbers are we talking about? What temperature can the LEDs run at safely?
If a halogen lamp runs at 2,930 centigrade, 3,200 Kelvin, yeah, it's happy. Yeah, that's where it wants to be.
Sure.
If an LED is run 85, it's at its limit. If it gets any hotter than 85 centigrade, you will lose light output, and you will lose color, and it will age faster. And if you come to 100 degree, then it's going to die.
So this must be an issue when designing lights, because if I want to make studio LEDs, which has certainly been the promise from many people that we're going to have a whole bunch of studio lights that are now LED instead of, and I'm putting them up in the ceiling, then it gets hot up there. It is
easier for the cooling of the LED if you have multi-LED panel lights. There it's easier to integrate cooling devices that keep them at a reasonable working temperature. But the moment you try to build focusing LED lights, you're talking about bunching together a big number of tiny little LEDs, the so-called dyes, into an LED array. And that will produce an enormous amount of heat. And if you try to get rid of that heat, disperse the heat with conventional cooling just by creating big surfaces and lots of cooling fins, then you would need tremendous cooling surfaces, and it becomes very unwieldy. So theoretically, there's a membrane cooling system with synchronized valves, and that causes an airflow called Nuventix.
But
theoretically very nice, but
noisy?
It makes too much noise.
Right.
It's above 30 dB.
Okay.
So that means no good for the professional world. All of our small focusing LED lights have what we call passive cooling, which means bringing the heat through a mixture of the right metals to guide the heat towards the heat dispersing elements, and the rest happens by convection, where if you look at these lights, then you can see through them. Yeah, we have air intakes around the lens, and the air can exit through the back, and there's an enormous amount of cooling elements there. The moment you get into real big lights like you may want to use in the studio, like 200 watt LEDs, you need to employ very modern cooling techniques, and usually what is done is to use heat pipe cooling as we know it from computer systems. But in a server, the installation is static. It doesn't move.
Yeah, it just sits there.
With a studio light, we may want to shine it downward, and maybe one day want to shine it upward. So even in the heat pipe, there are liquids moving, and they want to move up for the hotter part. So that creates the circulation of the liquid in the heat pipes. So we really would need two competing heat pipe systems, one for looking down, one for looking up. And one may be working more in this position, the other one more in this position. But you have to add large cooling surface and fans. And then it's called active cooling. And active cooling is something that makes studio users a little hesitant, because even if the light head is quiet when you buy it, you wonder whether it will be as quiet in 2 years. And when you add many of them, the sound may accumulate.
Accumulate up, yeah.
So we're trying to work now with a heat pipe, a double heat pipe system with 2 huge fans so that we can turn them slower, still have the air movement, and we're aiming at getting it down to about 16 dB. That, I think, would be acceptable even if you multiply the light sources.
Now tell me, is it true then, because the other thing about LEDs we all know and love is that they last a long time. So is that true? Is there any circumstances in the studio environment other than overheating that's going to run by LEDs?
If they run at the right temperature, they will give us an unprecedented long lifetime, which wasn't quite true 2 or 3 years ago. There's an internet forum called CML for cameramen and lighting people and grips. And Guy Brian Holt, a Hollywood gaffer, did a lot of tests, which may have been done 2 years ago or longer. And he claimed that only after 500 hours, LEDs would have lost 50% of their output. So this is changed.
But that wasn't your lights. That was back with somebody else's
Now,
lights.
the LEDs that we use and many others use may be in losing 10 to 15% over time of light output.
What sort of time frame?
The claim that is done, an LED will live for 50,000 hours. I think we can assume that it may come up to 20,000 hours. Maybe it's longer. But it all depends on the working temperatures. So, yes, the lifetime is longer. But there are some other distinct benefits with LEDs. You can dim them, the new ones, the modern ones. You can dim those with practical no color change. And the CRI value or TLCI values or even the camera-based evaluation is not going to change much when you run them at full power or half power, as long as they don't get too hot. So that is a distinct advantage. And that brings us into a new era where studio lighting may be daylight. Some studios have always wanted daylight, but we couldn't realize it because with the discharge lamps, what the studio also needs is to dim them down to 0. Was not possible because an HMI lamp will only dim maybe 30% at best, and then it loses color. And when you bring it down to 0, if you want to restart it, it's not instant restart, although it's hot restrike, but until it goes up to power and color, it needs some time, and that's not desirable for the studios.
Actually, it was funny you mentioned something about that. I always thought that kinoflows lasted a fairly long time, but you're pointing out that even in fluorescence, that hot striking a lot of fluorescence can really reduce their life, for example.
Let's assume a kinoflow lamp could live 5,000 hours. In practical life, in mobile use, it will never reach that because it will get broken by handling. But it could live 5,000 hours. But a fluorescent, or any fluorescent, be it a household or a professional kinoflow, is very susceptible in its color to heat. If you warm it up too much, it picks up green, even the kinoflow. So you have to watch out to get enough air circulation. And if you switch them on and off too frequently, they will suffer badly and their lifetime will be shortened drastically.
Let me ask you about the range of lights that you have using LEDs, because that's what we're talking about. So we've got some behind us here that you've been talking about, which are focusable LEDs. You also do make panel LEDs in a range of sizes.
Now, in the focusing lights, we're very proud that professional fixtures, let's say Fresnel lights, always worked with the same principle over the last 100 years. They have a spherical lens, part of a circle, just cut into onion rings to make them go flat. And you have the spherical front lens, you have a reflector, you have the light source, and that moves, and that's it. We were the first ones to add a second lens, and that gives us distinct advantages regarding the focus range, regarding the light distribution, regarding the light output. Then later on we upgraded that to non-spherical lenses, and we also have a focus system that includes 3 movements. Yeah, an extra movement for extra wide flood, an extra movement for extra narrow spot. So we have an unprecedented focus range where the small Studio Fresnel would do 1 to 3 intensity change in the center. A big 5K can do 1 to 6, maybe even 1 to 7. We start out with 1 to 25. Yeah? And we tried to transfer this optical principle onto the LED arrays, which are never one LED, but it's a bunch of tiny little dies. And each time you use a new light source, you have to redesign the optics to match that light source. Yeah? Then comes another LED that has slightly different characteristics, and we have to design new optics again. So what we're trying to do here is to transfer the benefits of the double aspheric optics and the zoom focus into the LED world to give us this huge focus range, to give us the even light distribution, and that presents on its way some new problems that we'd never heard of before.
The only reason I mentioned the light panels is because, wow, that's remarkable. The thing I like about your lights, what I like about your entire company actually, is that just when I think that you've sort of produced a standard approach to something, you come up with something from left field, and it just seems to be that you have a very inventive company. And I wanted to touch on an example of that, because you have many, many lights, but in the flat panel LEDs, which are an array of lights, you came up with one for going overhead that just had me fascinated, the 45-degree LED. I just want to use that as an example of just a bit of lateral thinking and a bit of inventive fun, because I thought it was just a brilliant solution.
Well, you just don't wake up and have an invention. It's many steps, and you develop idea and idea and idea, and you add to it, and then you go 3 steps forward and 2 steps backward, finding out what you dreamt about, and it doesn't work. In the multi-LED panel lights, we have higher light output than practically all competitors. What we're very proud of, and that is one big step in the direction of saving the planet, we use only half the power. One of our main competitors, with whom we originally started, and we helped them build the market, uses in the standard version 50 watt, and we have 35% more light, and we use 24 watt.
Yeah, and this is for about a yay big one by one
foot
panel,
by 1 foot panel. But it's always the quality of the light, and we're very proud that we're on a CRI scale, whatever that is worth. It does relate. We have 10 steps better color rendition than practically most of other competitors.
So where are you about on the CRI?
Others are in the mid-70s. We're in the upper 80s. And pretty soon we'll be in the 90s. That's where we want to be with professional lighting.
And just by way of comparison, cheap LED lighting would be down at like, what, 25, 35 on that scale?
No, on that scale, cheap LED lights are in the 70s.
Oh, okay. No, sorry, I meant street lighting type stuff, you know, the stuff you were talking about earlier, like...
Also those.
Oh, okay.
Yeah, can be. And they may have a higher light output. Because the better your color goes, the lower the light output.
Right, because you're trying to avoid that high 85 temperature kind of...
No, if you build one kind of LED light where you don't care much about the color, you can apply a different kind of phosphor, which gives you more transmission. It's always a blue light source and the phosphor layer, and the one that gives you the poorer color puts out more light.
Okay.
So there are LEDs that are actually about 100 or more lumen per watt, whilst the halfway usable ones are about 60 lumen per watt, and some of the ones that claim to have the ultimate color they're around 30 or 40 lumen per watt.
But I want you to swing back about this light of mine that I like, the one with the 45 degrees, and explain that.
On the multi-LED panel lights, light goes out like this.
Yep.
And the low-profile light looks like it had an accident. Light goes out 45 degree.
So literally, if I had the light like this, it's not casting light down from overhead. It's literally coming at an angle.
And that is very useful if you light anything that has a low ceiling. We've encountered that quite often when a TV channel bought an existing villa and calls an architect to make it look nice and calls an interior designer to build a kitchen studio, and 3 days before they want to go on the air, they call and say, let's put in some lights. But we don't want to see any. Yeah? So then we can stick those panels very close to the ceiling, angle them just a little bit, and have 45 degree light, and that allows us to do something that is not quite as awful as if the light would come straight above and you have dead eyes and so on. So even also for teleconferencing, where a business meeting room wants to be turned into a makeshift video studio, we can put 4 of those into the ceiling, DMX control them, adjust them, and have reasonable lighting.
I want to ask you a question about reliability, if I can, because the thing that I grew up when I was using Dedos for the first time is that they were just really robust lights. They were able to be put in the hold when you're flying on a plane, and you get out at the other end and you knew that they were going to work. I wanted to see if you could just comment, because I haven't had a chance to hear yet, how robust are the LED lights? How do they compare, your LED lights to your original Dedos? Are they as good in the hold? Are they?
Well, one aspect is the mechanics.
Yep.
How robust are those? What will break when they fall on the floor or when they're mishandled? In the halogen lights, really no invention of ours, we used low voltage. And low voltage we needed to use because an optical system wants a point light source, and that was to be found in low voltage light sources. The low voltage halogen lamps that we use cost a quarter of the high voltage ones, although they give the same light output. They live a lot longer, and they're practically unbreakable. So for halogen, one of the enemies is shock and vibration, and we're pretty much immune to that. So you can take a whole lighting kit, and we have a video where we throw it from nearly 5 meter height on the floor, and then the lady comes and opens the zipper, picks out the light, and it works. And that is of some importance if you travel, if you
yes.
check in the whole lighting kit and hand it over to the masters of destruction, the airport baggage handlers.
Yes.
On the HMI lights, we use light sources like everybody else, but they're not so susceptible to shock and vibration, and LEDs are not. So here, it's a question, how robust can we make the housing? But the light source itself is not that vulnerable. Yeah? And we haven't lost any yet from mishandling. So I would assume that we would be at least as robust and indestructible as we are with the classic low voltage dado lights. Any high voltage halogen is susceptible, can break very easily. But then also it's a question of feeding them, and our ballasts will go, the AC ballasts will go around the world. They go from about 85 volt to 270 volt.
Yeah, they're quite forgiving, aren't they?
And you just plug them in and they'll take care of it. And you can even shoot high speed.
The LEDs have no high speed. I was going to ask you about that, actually. The LEDs work for normal high speed and for sort of things like the Phantom?
Ours do. Others don't.
Okay.
Some others will, depending on the pulse width modulation with which they're driven, depending on the frequency, and some other details in the electronic. Yeah? So then the other aspect is dimming. The higher up you go in the frequency, if you come to the low end of dimming, you may notice some steps. Yeah? So we're just now developing a 16-bit dimmer.
Wow.
That will allow us in the studio to go all the way to 0 and have it as a linear dimming curve with no noticeable steps.
Right, because it doesn't want to be linear, does it?
Because some of the studios may want to dim during the show. Normally in a lighting situation like this, you set it up and you don't change it during the shot. So for the first generation of our ballasts, we could do that, but the studio demands going all the way to 0 and ideally doing that linear.
Well, look, it's been a tremendous pleasure talking to you and a real education in LEDs. I know that we could talk for weeks, but obviously I can't take up much of your time, but we love your lights. I want to thank you so much for being on the show, and thank you so much for taking time to talk to us.
Thank you.
Well, I want to thank Dedo so much for taking time to talk to us, and clearly this is a man I respect enormously, but he's probably forgotten more about lighting than I'll ever know. I also want to thank LEMAC in Sydney, and Tim in particular, because the guys have been great at LEMAC in helping facilitate that interview. Dedo's a really great guy, and it was a unique opportunity to sit down and talk to him.